Thank you for joining us today for Traits of a Prepared Engineering Graduate. You're going to hear Aaron West talk about the importance of a systems perspective, including defining requirements. So listen, learn, and be deliberate about being a prepared graduate.
Hi, engineering students. My name is Aaron West, and I've been working at Fleet Readiness Center East going on almost 18 years now. I graduated from Ohio University with a degree in mechanical engineering in 2003 and started my career with FRC East shortly thereafter. My current position is lead engineer for the H-1 helicopter fleet support team, which provides global engineering and logistics support to the H-1 helicopter fleet. Of the about 120 team members, I lead 70 engineers that provide the technical products and services required to keep the aircraft flying and safe. And of course, supporting the entire aircraft, we have a variety of engineers that work on the team, primarily mechanical, aerospace, electrical, and industrial. Today, I'll be talking with you about trait number 8, which is the importance of being able to utilize a systems perspective, including defining needs and requirements. So I first want to say, I think it's pretty obvious the work that we do at FRC East is mission critical to our nation's defense. In all aspect of our work, the warfighter relies on our expertise and our services to meet their needs and ultimately meet the mission. It's critical that we're not only get it right, but that we're providing viable and executable solutions. This trait number 8, is kind of the starting point to that for obvious reasons. So the first step in that is requirements definition. If you don't have properly defined requirements or they're not clearly understood, you're gambling, you're rolling the dice. You may get it right, but you may not. So this is where asking questions and understanding all aspects of the project, not just the technical aspects, come into play, as well as understanding the end user's requirements. So I have this cartoon that you may or may not have seen, but it can be interpreted in many different ways. In this case, I'm talking about the end user's requirements, which is this tire swing tied to a rope to a tree. And these are all the different aspects of the program that produce something very, very different. So the first one is how the customer explained it, how the project leader understood it, how the analyst designed it, how the programmer wrote it, how the business consultant described it, how it was documented, how operations installed it, what the customer was billed, how it was supported, and what they ultimately needed was a rope swing. So a very simplistic picture, but it really shows why it's very important to get the requirements right, to understand what the user needs and wants, and to get all the different aspects of the project, not just the technical aspects, in alignment with that. So once you understand the requirements, it isn't just your job to design a perfectly engineered solution, because the solution has to be manufactured, it has to be usable, it has to be affordable, it has to be maintainable, it has to be sustainable, and just about every other able that you can think of. So it could be the perfect technical solution, but it's unaffordable. So there's many aspects that you have to fold into what you're doing as a mechanical engineer. So for the engineering piece of a given project or problem, there's even intricacies within that where what you're doing impacts other technical disciplines, and what other technical disciplines are doing is impacting what you're doing. So understanding how the systems play together and how everything integrates together is very important to doing your job. Now, this isn't to say that you need to be an expert in all these areas. It's the opposite of that. It's having that top level understanding, or at least in enough detail for a specific project that allows you to do your job effectively. You're going to involve the SMEs or the subject matter experts from other areas to make sure you have a fully viable solution. But if you understand that personally, at least to the level necessary to be able to apply your mechanical engineering expertise, then you're going to get a better solution every time. So on the other elements of systems level thinking, on the programmatic project side, you have to be able to get parts, you have to be able to manufacture it. There's many engineering solutions that could never be manufactured because it's either really difficult or impossible, too tight of tolerances. We could come up with lots of examples there. The fleet can't maintain it. It's the maintenance requirements are too stringent and they just won't use it, or it won't meet their needs because it needs to constantly be serviced. So there's lots of things you need to think about, especially when you're dealing with the fleet that operates in austere and adverse environments with their equipment. So all of this is really important to understand. You need to understand enough to ask the right questions and provide the best possible solution to the fleet. And always keep in mind that sometimes, actually most of the time, there's going to be multiple right answers, multiple technical right answers. And you might not have to pick, or you might not have the opportunity to pick the best one because of all these other aspects we just talked about. So there may be times when you have to compromise where the solution isn't the best one technically, but it will work. And you have to select that one because it meets all the other requirements of the project. So I recognize some of this may sound like common sense or easy to do or pretty easy in implementation or execution, but I assure you it takes a concerted and focused effort to master. It's easy to get tunnel vision and stay focused on just your elements of the project and just the technical elements of an effort. It's not as easy to take a few steps back and look at it from a systems perspective technically and from a systems perspective programmatically. I encourage you all to start this learning journey from day one of your career. Listen and learn. You're not going to know everything from day one, and you're not expected to know everything. So listen and learn. To everyone involved, especially the end user, I can't stress that enough. The end user input is critical to what we do. Never assume. Listen to your gut. Your gut is telling you something for a reason, so listen to that. Don't fall into the trap of this is someone else's job or someone else's area, or surely someone else thought of this, because most of the time, I assure you they haven't. Or if they have, maybe not fully. So make those concerns known and make sure that your piece of the project, no matter how small or big, is implemented correctly and integrates well within the entire system, the entire solution. You're also going to learn about the systems engineering processes and technical reviews that we do with big acquisitions and even some small ones as well. Those are all important aspects to understand and apply to what you're doing, because that's going to help inform the design, make the design better, refine it, and it's going to apply that systems approach to the projects. However, all the things I've talked about, the systems level thinking, can be applied and practiced every day in what you do. You don't have to wait for a technical review to think on a systems level. So I encourage you to practice that and work on that every day, starting now, and especially starting day one of your career. So thanks for listening. I wish you all the best in your engineering career as you finish your education and as you start your career.